When we talk about the artificial intelligence boom, the conversation almost always centers on the microchips. But beneath the pristine exterior of these modern data centers, the entire revolution relies on miles of heavy metallic wiring hidden right in plain sight. If you open up a single top-tier rack-scale system like Nvidia's Vera Rubin, you will find an astonishing amount of physical infrastructure. A single chassis contains roughly 5,000 individual data cables. String all of those connections together, and you have 2.5 miles of dense copper wire crammed inside one machine. This metal network acts as a nervous system. It's the physical pathway that allows hundreds of individual graphic processing units to communicate back and forth, syncing up to act as a single, unified superbrain. But moving data through these lines requires transmitting electrical signals. Pushing those physical electrons through metal demands an immense amount of power, and as a result, generates a massive amount of heat. The industry is fast approaching a literal copper wall. If this foundational plumbing isn't replaced soon, future data centers will simply run out of electricity to keep these systems running. As AI models grow larger, they demand more hardware. Training them requires scaling up from a few dozen GPUs to clusters of hundreds or even thousands. Physically, that means the individual chips have to be placed further and further apart from one another. Look at this chart. As the gap between chips grows, the power to push electrons across that distance spikes exponentially. There's a secondary penalty, dropping speeds. The longer the journey, the slower GPUs communicate, creating a latency delay that throttles the entire system. Up until now, no one has been able to solve this specific equation of power and distance at the microscopic scale required deep inside a server rack. To keep the AI industry moving forward, engineering a faster microchip isn't enough. The hardware requires a change in the basic physics used to move data. The solution to this modern hardware crisis is coming from a 175-year-old glass manufacturing company named Corning. Back in the 19th century, Corning provided the specialized glass enclosure that made Thomas Edison's incandescent light bulb practically viable. They followed that up with a string of industrial leaps, from inventing durable Pyrex cookware to producing the heavy glass cathode ray tubes required for the first consumer televisions. They continued to adapt right into the modern era, engineering the glass vials necessary for COVID vaccines and the scratch-resistant screens for the original iPhones. Corning's corporate history follows a specific pattern. They arrive exactly when humanity hits a technological ceiling, and they engineer custom glass to break through it. Today, they are applying that exact same playbook for Nvidia. In a massive expansion, Corning is currently building 3 new, dedicated factories in Texas and North Carolina. Their sole purpose is manufacturing products to solve Nvidia's data bottleneck. The breakthrough they are working on is a technology called co-packaged optics. It involves replacing those 5,000 heavy copper cables with incredibly thin, bendable strands of glass. This changes the physics of the server entirely. Instead of dragging data through metal using electrical signals, this system shoots data down the glass as pulses of laser light, moving data as photons. This chart illustrates the massive efficiency gap. Moving data via photons through glass uses 5 to 20. Because fiber optics transmit data at light speed, the communication delay between GPUs drops to 0. The machines act instantly. Co-packaged optics rewrites the physical limits of what an AI server can do. It strips out the extreme heat and physical friction of copper, replacing it with the efficiency of laser light. This physical redesign isn't limited to a single Nvidia experiment. The entire tech industry is actively pivoting. Meta has already committed up to $6 billion strictly for Corning's advanced fiber. Across the industry, OpenAI, AWS, Microsoft, and Google are all in the process of rewiring their massive data operations with this AI-optimized glass. Fiber optic strands have moved from the backbone of the data center campus into the internal circuitry of the machines. These cables are being threaded deep into the individual server units. As these AI nodes inevitably expand to house thousands of GPUs acting in unison, the physical distances between them will continue to climb. Only glass makes traversing those distances economically and physically viable. The 2.5 miles of heavy copper burdening older generations of servers is being left behind, replaced by hyper-efficient, light-driven networks. Silicon chips may be the primary focus of the AI boom, but the survival of the entire